Start. Okay. Now already we have to discuss a pre-calculus. Pre-calculus is a deals with velocity, acceleration, tangent line, slope and so on. Without a mathematical application we can't do anything in engineering. Okay. Now one thing is a formation. Now first we have to know about the fundamental difference between pre-calculus. What is pre-calculus and what is calculus? First you have to know about the basic concept. Fundamental difference between pre-calculus and then calculus. Pre-calculus is a more static. What is static we have to discuss later, and then calculus means more dynamic. Okay, this is a very important one. This is a more statics and more dynamic. Then next, the example. What is the example between the pre-calculus and calculus? Pre-calculus is an object traveling at a constant. We have to take one chalk bus, we can or otherwise we can just this chalk bus, it couldn't mean stable in a same place, it not moving, it does not in a moving, it does not in a traveling, because it is as it is, we have to keep it as in a same place, we can't move anything here. So this is a constant object, this is a constant, we can't move here, this is stable here, it is a constant object traveling. Object is traveling at a constant velocity. Object is traveling at the constant velocity. This type of the velocity we have to using the pre-calculus. Velocity means we have to know about v equal to x by t. V is equal to x by t. We can apply the rate of change. If it is a moving, it is a constant x by t only. X is a distance and t is a time. Okay. Then next to analyze, and then calculus means what is calculus now? To analyze the velocity accelerating object. Velocity it could be in a move, that the object will be traveling constantly, and it could be traveling. So first what we have to do, dx by dt, we have to apply dx by dt, rate of change of x, rate of change of time. Okay, we can find. And then acceleration means we have to using the second derivative, dou square v. You can take the second derivative, dou square x by dou t square, we have to take like that. Okay, we have to take like that. To analyze the velocity of an accelerating the object, we have to calculate by using the calculus. Pre-calculus means object traveling at a constant. So velocity, constant velocity now we have to using a pre-calculus, and then analyze the, we can after you have to taking that velocity, you have to analyze velocity of an accelerating the object now we have to using you need in a calculus we have to apply. Next another one example, the slope of the line. Already you all know what is a slope. It is a slanting line is a slope. For example, this is your slope, this is a slope, y is equal to mx plus cu. M is a slope, this is x, this is y. So we can find the slope. The slope of the line can be analyzed with a pre-calculus in mathematics. This is the slope of the line you can find. Okay. Then next another one is another calculus means what? To analyze the slope. First you have to slope of the line analyzed. First you have to slope of the line we have to analyze. Then pre-calculus you have to analyze. Then what is next in a slope of the curve. Slope of the curve, it could be, for example, you have to using the curve. Okay, you can just arc that curve, analyze that curve, you can measure that line. Okay, you have to measure that line, analyze the slope of the curve, you need to the calculus. Next another one is a tangent line. We have to using the tangent line also, you have to using a pre-calculus we have to apply. Tangent line to a circle can be analyzed with the pre-calculus. What is tangent now? A line touching on the curve. This is a curve now. A line touching on the curve. This is your tangent line. This is your tangent line. And then this is your perpendicular. This is your normal. This is your normal. And then the tangent line to a curve, to a circle can be analyzed with the pre-calculus mathematics. Next, what is calculus? With the help of this tangent line, you can analyze the area under the general curve. You can find the area. To analyze the area under the general curve, you need a calculus. Next, another one is very important one, area of the rectangle. You can find the area of the rectangle can be analyzed. You want to find the area of the rectangle value now. So we have to using first a pre-calculus. Then to analyze the area under the curve, you understand? To analyze the area under the curve, you need the calculus. First you have to draw the area of the rectangle. First you have to analyze that, can be analyzed, you will get in a pre-calculus method. Then after that, before calculus, you have to find the pre-calculus, you have to know about the data. After you have to apply the calculus, analyze that, you can analyze, you have to getting the data, no, statistic, dynamic data, no, to analyze the area under the curve, we can find the calculus. Remark, calculus is a, simply have to say, what is calculus? Now, calculus is a limit machine. What to say? Calculus is a limit machine, involves the three stages. Involving the three stages is a very important thing. Easily you have to stay. Before first we have to discuss the introduction. What is introduction? Who is the father of calculus? And Augustin Louis Cauchy. He was a father. He was born in Paris, and then he had to doing there so many roles. He was playing so many roles in a differential calculus, limit and continuity. And then limit, we have to, in this chapter we have to using the limit and graphical representation only. We have to using how to use a limit. And then how to use the continuity, we have to see on, we are going to the problem, we have to discuss on later. First you have to know about the what are the three stages. Calculus is a limit machine involving the three stages. The first stage is pre-calculus. Already you all know about, what does it say? We have to discuss in a pre-calculus, slope of a line of the area of a rectangle. Slope of the line, area of the rectangle, we can find. Slope of the line, now what do you have to find? You can analyze the slope of the line. Already you have to know about, there is a slanting line only, we have to know about the slope of the line, and then area of the rectangle we can find. Second stage is limit process. You have to get the one value. For example, limit, we can give there a limit. For example, limit extend to 0 some function f of x. Okay, that limit is, which is equal to L. Okay, that function we have to apply the limit on x. We have to apply the limit on x. It is a right hand limit or left hand limit, whatever it is, depends upon that question, depend upon the function. We have to using this limit. You are not getting the 0 or otherwise infinity now. We can limit does not will be exist. Okay, the function will be, we have to, they given the some function here x, then for example f of x is equal to x, you can apply the f of x is equal to x or x plus 1 we have to apply. Now we can apply the limit extending to 0 x plus 1 which is equal to what? We have to apply the limit x is equal to 0 plus 1, I will get a one limit which is equal to what? Which is equal to one constant limit. I getting the limit. So if it is I am getting the limit will be exist. Why? Because we have getting the some value. So if I get the infinity now, the limit does not exist. The function does not exist. Okay. So first what is you know about the pre-calculus? First you have to find the slope line of the area of the rectangular. You can find, this is your slope line. You can find there in a small sheet of box. You can just put it in grid. So I want to need the area of the rectangle. This part only I want to need. So I will get the whole values. So we have to using this. The first stage is pre-calculus, slope of a line of area of a rectangular. Second stage is a limit we have to apply. Limit process we have to apply. A limit extend to x naught. Limit extending to x naught. We have generally we have to write it here. Limit extend to x naught is equal to f of x equal to L means some function, some value you have to getting. Then third stages is new calculation formulation such as derivative or integrals. First we have to come, first stages we have to apply the slope of the line, then near the function y equal to some function f of x we have to getting here. Then that with the help of the pre-calculus function we have to apply the limit, we have to processing on the function, we have to apply the limit x approaches, the function approaches, x is approaches to the some limit, x is equal to x naught or x is equal to 0, x tends to 0 or x tend to a, whatever it is, integer, whatever may be. You have to apply, you have to get the value in a constant value, constant element you have to get, now limit will be exist. Third stage, you can overcome the third stage. When you apply the third stage, if it is not a limit, you have to apply the limit, your function is not, does not exist now. We can apply there are derivative rules. We can apply the L'Hopital rules and then our otherwise our integrating whatever it is depends upon the question. We have to derivative such a formulation such as a derivative and then integral we have to apply. That is a new calculus. So already we have to getting the answer. First and second calculus is enough. Third is a new calculus we have to apply. You can take the given function, you have to take the derivative, then after you have to apply the limit, then you will get the limit will be exist. Okay.